Now in this lecture we'll talk about Wurtz reaction. Wurtz reaction. This reaction is mainly used for making alkane. And one should keep one thing in mind, it is only used for making even number of alkane. Now you would be thinking, what do you mean by even number? The number stands for carbon. Okay, and this is one of the biggest, what I'll say, limitation of this method. This is the biggest limitation of the method. First let's see about the general reaction. In this reaction you have to take two alkyl halides molecule and treat it in presence of dry ether. So we'll have alkane plus alkyl halide. Let me tell you first the purpose of taking sodium. The purpose of taking sodium over is it acts as a reducing agent. Not only sodium, if you are taking any metal in particular reaction, it will be always a reducing agent. The purpose of dry ether is to act as a solvent. The dry ether acts as a solvent over here. Okay, now why we take solvent in a particular reaction? In solvent generally what happens, suppose there is a reaction mixture inside which you are having a solvent. Okay, along with this, suppose if you are having your reactant, okay, and if you just stir it by using a stirrer, okay, so now what happens, they are getting collide among themselves, and due to this collision the reaction takes place. In my another video I'll explain about the Arrhenius theory of collision. Arrhenius theory of collision, very essential for a reaction to take place. This theory explains the mechanism behind the reaction. Now let's talk about the mechanism. What happened in this reaction? Take an example of CH3Cl. Okay, in first step sodium loses electron to become Na plus E minus. In second step this electron has been taken by alkyl halide to form a free radical plus chloride ion. Now this free radical combines with another free radical to form an even number of alkane. The main problem comes over this particular step. Suppose if you are having odd number of alkane, if you have to prepare odd number of alkane such as CH3, CH2, CH3, for that you need to take CH3Cl plus C2H5Cl. Now what happens, you will be having two type of free radical, CH3 free radical and C2H5 free radical. Now there are chances that there are three possibilities. First, either CH3 free radical will react with CH3 free radical and it will form a product C2H6, or secondly CH3 free radical will combine with C2H5 free radical to give you a product of propane, that is C3H8. and in this the third possibility I am talking about, two molecules of C2H5 may combine among themselves to give you a butane, that is C4H10. So one should avoid always the Wurtz method for preparation of odd number of alkene. Now again one thing, many students are having doubt, why only sodium?